Hello everyone, my name is Thomas Powers, and today I'll be taking you through my journey and vision of becoming an expert in advanced structural engineering, specifically for hypersonic vehicles and nuclear reactors. So, a little about me as we warm up. I worked at GTRI doing anti-drone warfare for the military, that is the Georgia Tech Research Institute, and I worked in sensors as well as on planes themselves and the technology that goes along with that. I also designed supersonic rockets and planes for YJSP and Georgia Tech Supersonic Club, YJSP being the Yellow Jacket Space Program. Um, Obviously, I did our Kármán line reaching rocket for YJSP, and I worked on our subscale hypersonic vehicle for GTSC. I also designed nuclear reactors that power our nation's Navy's submarines at the Naval Nuclear Lab in upstate New York. As a mechanical engineering student at Georgia Tech, with all this experience I've just talked about, I've developed a deep passion for designing and analyzing high-performance structures that push the boundaries of engineering. Through this presentation, I'll discuss the significance of structural engineering in these fields, the current innovations, future trends, and the skills necessary to become a leader in this domain. So, in industries like aerospace, defense, and advanced manufacturing, every decision we make must balance performance, efficiency, and cost to get the job done. That's why I've chosen 4 engineering methods that I believe are fundamental to designing and manufacturing better products. First, the importance and challenges in the field. Second, the technology and innovations. Third, the trends and future opportunities. And fourth, essential skills for success in this field, or what you need to learn or have on your resume to really stand out. These are categories that help put the topic into perspective, defining it so that a roadmap can be made to becoming an expert in the field. First off, we have the importance and challenges. So, why is structural engineering critical to nuclear and aerospace? Hypersonic vehicles operate at speeds greater than Mach 5, meaning they experience extreme aerodynamic forces and intense thermal loads. The challenge is designing materials and structures that can withstand these conditions while being lightweight and reusable. This is vital for applications in defense, commercial space exploration, and high-speed transport. According to a report by the U.S. Government Accountability Office, or GAO, hypersonic systems are a major defense priority, with over $15 billion invested between 2015 and 2024 solely to accelerate research and development. Nuclear reactors, on the other hand, present their own set of engineering challenges. They require materials and structural designs that can endure high radiation exposure, thermal stresses, and long operational lifetimes without failure. In terms of submarines, this can possibly sometimes mean up to decades, possibly 40 to 45 years. Whether it's for submarine reactors or next generation small modular reactors, or SMRs, ensuring structural integrity is paramount for safety and efficiency. The International Atomic Energy Agency highlights that advancements in nuclear designs, such as molten salt and high temperature gas reactors, are making nuclear power safer and more sustainable. Now let's talk about cutting-edge technologies making these structures possible. First off, additive manufacturing, or as you probably know, 3D printing. It's revolutionizing aerospace and nuclear industries by enabling the production of intricate, high-strength components using materials like titanium and Inconel. The Department of Energy has been actively funding research in metal additive manufacturing to improve reactor component fabrication. Now, this has been going on for years, and I saw this at Naval Nuclear Lab with some of our components being manufactured with metal 3D printing, and it costs much less money. It takes less time for design work, and obviously it speeds up project timelines. We also have composite material advancements, and these help reduce weight while maintaining structural integrity and is crucial for both hypersonic and nuclear applications. So continuing on with technology and innovations, Second, we have finite element analysis and AI in structural design. So, simulation tools like Abacus and ANSYS allow engineers to predict material behavior under extreme conditions before physical testing. AI-driven material optimization is also helping to create structures that are lighter, stronger, and more heat-resistant than ever before. And we also have carbon-carbon composites and ceramic matrix composites. And these are both critical for hypersonic thermal protection. Nuclear reactor structures benefit from refractory materials that can endure high neutron flux and heat. So now we're going to be looking at the trends and future opportunities, or the future of hypersonics and nuclear engineering. So looking ahead, the demand for hypersonic technology and nuclear innovation is growing rapidly. Some of these key trends include: first, the development of next generation reusable hypersonic vehicles to improve cost efficiency and testing capabilities. Obviously, if we have reusable hypersonic vehicles, the cost to test and also, produce goes down a lot, because maybe we produce only one every few years instead of 4 or 5, because it's reusable and it takes much longer to wear out. Second, we have nuclear fusion and modular reactors. These could revolutionize energy production and space travel. Now, what I mean by this is currently our space travel works primarily with gas power, burning fuel, and they don't work on nuclear reactors. But introducing nuclear fusion and modular reactors to space travel will make it much more cost efficient and also make it safer, because it'll be much harder to run out of fuel. Now, fusion energy. This is a viable power source within the next few decades. With advancements in materials and reactor designs, every year we're getting new news that we're getting closer and closer to this becoming a reality, and soon it will be one. Finally, we have automation, AI, and digital twin technology. Now, this can help us enhance structural design and validation, of course, because we can simulate these things that we want to build in the real world before we actually build them, so we can test planes, nuclear reactors, structures before we even produce them. This saves immensely on cost, and time to production also, of course, gets a huge bonus. So now we're moving on to essential skills for success. Many avenues can be taken when wanting to become an expert in structural engineering. Technically, proficiency in finite element analysis, or FEA tools, such as Abacus and ANSYS, as well as CAD expertise with SolidWorks and NX for designing complex structures, and a strong understanding of material science to select appropriate materials for extreme environments will all help immensely. Personally, at my internship at NNL, I used FEA, specifically Abacus, to do structural analysis on the reactor vessel itself to make sure that the sailors would be safe no matter what loads it would be experiencing. I also have done CAD work using NX and SolidWorks, mainly for designing a rocket with YGSP, designing the stringers, which is the internal skeleton of the rocket itself. And of course, material science for extreme environments will be essential, because hypersonic vehicles, as well as nuclear reactors, undergo intensely variable thermal loads, and you need to be ready for that. For manufacturing, hands-on experience with 3D printing and composite fabrication, and knowledge of structural testing methods to validate designs would both help a lot. It's easy to do 3D printing. You can buy a 3D printer of your own or work with one through your school. Industry knowledge and networking. So staying up to date with advancements from defense contractors, DOE, NASA, and private aerospace firms, as well as engaging with professional orgs and conferences to connect with experts in the field, will give you a huge leg up. Do not underestimate that. Here are my sources. All right, to wrap things up, structural engineering in hypersonics and nuclear reactors is an exciting and rapidly evolving field with immense potential, specifically given DOE and military funding going through the roof, and increasing every single year. Through cutting-edge manufacturing techniques, advanced materials, and AI-driven optimization, we are pushing the limits of what's possible. My goal is to continue expanding my expertise in this area, contribute to technological advancements, and help shape the future of high-performance structural design. Thank you for listening, and have a great day.